So 1 times 3 is 3 plus 1 equals 4, right? So that would work. So 1 times 3 equals 3 plus 1 equals 4, which works. Let's try this one. So 2, which is our n, remember? So 2 times 3 equals 6 plus 1 equals 7. So that one works. So I think we might have a winner, but let's keep checking. So 3 times 3 equals 9, and then plus 1 equals 10. So that works. So let's try and do this for the rest of them. So 4 times 3 equals 12, plus 1 equals 13. 13, and I'm noticing when I'm going down here that there's a relationship between all of these numbers. Like for instance, 4 and 7, there's a difference of 3, and there's a difference of 3 between these two and those two. But I can also see the difference between 1 and 4 is 3, and the difference between 2 and 7 is 5, and the difference between 3 and 10 is 7. So it's going 3, 5, 7, which I would assume that if we kept going, that it would keep going up by 2's this way, or this way. And then if we kept going down this way, all of these would be going up by 3 and 3 and 3. But let's keep going because we need to fill out this whole table. So 5 times 3 equals 15, plus 1 equals 16, which would work because 6, and the difference between 6 and 13 is 3. So 6 times 3 equals 18, plus 1 equals 19, which is, again, 3. There's a difference between 3. So 7 times 3 equals 21, plus 1 equals 22, which is the difference between 2. And this one's 14, because I'm going to jump, because I want to be able to get multiple numbers in a sequence, or in a line. So 14 times 3 equals 42, plus 1 equals 43. So 20 times 3 equals 60, plus 1 equals 61. So 61. So our rule, remember, we said this plus 3, this times 3 plus 1 equals the number of sticks. So we would write that n times 3 plus 1 would equal the number of sticks. Number of sticks. So n plus times 3, which these are our n's because this is our variable, times 3 plus 1. So you would do this times 3 plus 1, which would give you this. And you can see the relationships because these are going up by 2, like the difference of them. Like that one's 3, 5, 7, and then we go on and go on. And then between these two numbers is 3. So that's another way that you can check. And using this kind of table to figure out your rule is really important because it's a visual way for children to be able to see and figure out and double check, because they can go back and check and write it all out, and they have a table. Or you could use one like this too, but it's kind of small to see on the camera. But they're great ways to be able to show the relationships between numbers because it's right in front of them and they can kind of construct it themselves. Okay, well, that's it. Thank you.